Okay, so let's start with today's topic, that is what is electricity and what is electric current. Today we are going to study about this topic, what is electricity and what is electric current. So let's start. As we can see here, electricity is nothing, it is a form of energy, and this energy can be transformed into some other forms of energy. As we know that in class 9th we have studied conservation of energy, which says that energy of any system can be transformed into other forms. Similarly, electricity is also a form of energy which can be transformed into different forms, like we can convert it for light, we can use it for communication, we can use it for heating and cooling, as you can see here. Okay, so basically these are the forms to which we can convert electricity. In the further chapter we will discuss the more about that how to convert this electrical energy into other forms. Now coming that what is electric current. Okay, so basically electricity we can say, or electric current is related to the word which tells in dictionary that something which is moving, some particles which is moving, known as current. It can be air current, it can be water current, it can be electric current. So basically flow of electric charges is known as electric current. So here we see the definition. It is the rate of flow of electric charge or electrons through a conductor is known as electric current. Okay, so this is the definition of your electric current, as in our sacred book of NCERT it is also given there. You can see here in our NCERT it is written there that it is the rate of flow of electric charges. So very simple definition is there of electric current, which is measured with respect to time. That rate of flow, rate means time, and flow of electric charges means electric current. So very simple definition is there. Now coming back, okay, so the formula is I is equal to Q. Q represents charge and T represents time. So formula is I is equal to Q upon T, that is Q is equal to NE by quantization. We are not going into deep into that, but we will keep this formula in our mind, that I is equal to Q by T. Now the unit, which is very important, unit of current is coulomb per second, or it is commonly known as amperes. So basically current is measured in ampere, represented by a capital letter A. Again, it is a scalar quantity. That means there is no direction of electric current, but I would say in electricity is given there in our NCERT also, that conventionally in an electric circuit, direction of electric current is taken as opposite to the direction of flow of electrons. So basically if electrons are flowing from negative terminal of the battery to the positive terminal of the battery, as we know that there are two terminals in a battery in a cell, so basically electrons flow from negative to positive, then current direction is taken from positive to negative as in back. So there is no direction, but yes, this only shows that what is the direction of current. Now how you can measure electric current. A device known as ammeter is used for measuring the electric current. Okay, so here is a symbolic representation. This is ammeter here, you can see. So this A is written there. In some devices a small m is also attached, which is representing ammeter. Okay, so this A represents amperes actually, not ammeter. Okay, but if you see A, that means it is an ammeter, because here you can see some readings are written, but we will, in our next discussion we will see how it is calculated. Okay, we will talk about the least count also in the further sections. And also this ammeter, you see ammeter here. Okay, so this ammeter is always connected in series. As you can see, it is written there, it is always connected in series in a circuit. So ammeter is connected like this in a series. You can see those two terminals, one is positive, one is negative. So in our circuit diagram, this is positive and this is negative. So ammeter is connected in series in any circuit. Again, there are some readings like 1 milliampere represents 10 to the power minus 3 amperes, and 1 microampere represents 10 to the power minus 6 amperes. So remember these small things. Example number 12.1. Current of 0.5 ampere is drawn by a filament. Drawn means used by a filament of electric bulb for 10 minutes. So time is given there, I is given there. You have to find the amount of electric charge. So this is your assignment for today's lecture. See you soon in the next lecture, and we will discuss that why does the electric current or energy flow.